الاستعانة بصديق يقول لك كذا تحتاج تعرف انه غلط الكود والله مصيبة.
Okay, now the next one,
unstructured.
UN.
Unstructured.
So UN, and then I have to add a little piece of code because UN, I'll show you why we are doing this. The UN is just unstructured. It's adding more parameter to the model. So we need to make sure that to adjust for the degrees of freedom. And in order to adjust for degrees of freedom, we have to add 2 pieces of code to this model like here. So everything will be the same. The type it will be UN instead of CS. And now we make sure that to add these 2 B's.
HLM.
Is it HLM and some. This would adjust for the degrees of freedom because we are using unstructured. Only these 2 B's of code used if you are using what? The unstructured. Just make sure if this is given in the exam. When you are using unstructured, make sure to add these 2 B's. Otherwise, it's going to give you a different AIC. Okay? So now we just need to add H and L. These 2 B's now we can run the UN. I can show you the code here. All right. Yes.
If we don't add the HLM, it won't happen.
Remember, I'm going to use what? To convert this model, I'm going to look at this, the AIC. Likely sometimes this may change if I don't put that 2 bits of code. Okay. So again, these are the parameter added. See that? So you're adding more parameter, maybe a 10 parameter, if you are using this various covariance structures, which is unstructured. This is the AIC you're going to convert for that. I'm going to come back to this and put a table for each model, and then compare and come up with my best model. So this is the UN. The next is, I'm going to continue, all right? So now the next will be autoregressive model. So autoregressive model, the only thing I need to change is still R core is the same thing here. I'm going to remove the 2 piece for unstructured. I'm going to add AR parentheses 1. This is for autoregressive model. How this work? This is assuming that if you are doing the correlations, you're assuming correlation between time 1 and time 2 is 0.4. Then the correlation between time 1 and time 0 it will be 0.4 times 0.4. So these are dependent, level of dependent correlations. The way how this you can look at. So basically, if this is 1, this is for the first time. So now you will see here squared, and now you will see here to the third. So as you can see, if you start with the correlations, this is 1, the first one, and then you start that just like you're multiplying for each one to get the second one. So these are dependent on the previous correlations. If you try to get this, so you just multiply this by itself, you're gonna get this. And if you're trying to get this, just multiply the previous two correlation, you get this. And if you try to get b to the 4, you just multiply these, the previous correlations, you're gonna get. This is how the how this works. Similarly, it depends on the previous correlations. So if you know the previous correlations, you can get the next correlation by multiplying the previous correlations together.
ليش point 4 لأنه 4 weeks؟
Point 4 is the correlations. This is just an example.
In this case, what is the correlation?
Why we need this? What does it mean? ها؟ يعني طول الترم مسألة الاتصال مش
I think
why we look for correlation؟
okay.
عشان كده
It's all about
أعطينا الفكرة من
the variance.
الموضوع.
Okay, if I draw this, so these are the matrix, alright?
هذا شيء جاتنا في الاختبار حافظينها.
Yes.
diagonal ولا
Yes. Now diagonal when let's say we have 4.
reflect that they are the same, not
Yes.
one. Reflecting.
Yes,
simple
these
that
are the same.
the same.
Now look at this here. This is the correlation. Let's assume the first one. The correlation is P. It can be anything. Can be 0.4. Can be 0.2. Can be 0.1.
Yes.
It
Give
is
the
a-
example point 4, right?
yes, example 0.4.
Mm.
The second one would be just like you multiplying will be 0.4 squared. Just like you multiplying 0.4 times 0.4. Okay? And the third one would be just like you multiplying them 3 times. 0.4 times 0.4 times 0.4. Right?
This is not real.
It is just trying to find the better way to model your data. Yeah, and now look at this. This is let's say this is you have a b here, and what would be this? Thank you, b squared. Right?
This is from point of view of a statistician. I am talking about what's the aim.
The
يعني أنا أوكي سويت مجرد طيب بعدين أنا أعرف إنه عندي داتا. خلينا في البيزك things. أنا عندي داتا.
Yes.
Why is I got it serial.
Yeah.
When I dealing with data, with this data, I am dealing with the variance. That means the difference between my data reflected with the baseline. Give me the variance. Variance. I'm talking about variance. هنا ماني فاهم. هنتعامل مع الداتا ولا مع الفاريانس؟
Okay.
ولا الكوفاريانس؟
Okay. إذا بدنا نتعامل مع الداتا الحين let's assume that the correlation. Remember, this is the time one, right?
صح.
This is the first one, or week one if you work with week 0.
اوكي.
This is week 0.
معلش السؤال في نهاية السنة.
This is week 1.
Yeah.
This is week what? 4. This is week 6, right? So now, if you know the correlations, the correlation between week 0, the baseline, just you mentioned it, and week 1 after 1 week after the baseline, if you know the correlation, let's say that the correlation is 0.4. So now put that 0.4.
Yeah.
Now, you know, once you run the type equal, will give you the correlation matrix, will give you everything.
طب good. يعني now I am dealing with correlation.
Yes, this is the correlation.
Good. Now يعني الداتا انساها. I am dealing with correlation.
Right.
Good. I plot the correlation. Sometimes it comes equal, diagonal.
Yes,
and
sometimes,
bar,
yeah.
And sometimes like what we have here
Yeah.
in the last running, everyone it has its own except the diagonal.
Yes.
It's the same. Which is reflect is the same. يعني one should be the same.
Yeah.
Otherwise there is something. طيب. Then next step we run the model.
You have, yes, this is why the choice. You have like 5-6 models. You have to run all of them,
Good.
and then
Looking for the number whatever.
And then that numbers will tell you which one is most appropriate to model this data.
To choose it.
There is no perfect way give you 100%. You see?
يعني الchoicement based on that number.
Yes.
That's all.
Yes. So basically, based on that numbers, you will have like a tables comparing that numbers to different models, and then the one with the smallest AIC, that would be your best model to model this data. You don't have to look at the correlation yourself and decide whether this is following exactly this or not. Visually, it is hard, but how you compare, we're looking for the best model that can fit our data. Okay, so again, this is just how you're going to model this. If you know this is 0.4, then this will be 0.4 squared. Then this will be 0.4 to the third. If you know this is 0.2, then this would be 0.2 squared. Okay, and so on. So here, this here would be what? The same, exactly same as those, remember? Yeah, it's not gonna be different. So now we just need to put what here to get this done. And instead of type, what we say?
You are.
So just say,
Doctor, the variance always become A1 equal to 1.
which one the variance?
The variance.
For this autoregressive, yeah.
Always equal to 1, right?
For the autoregressive, yes. If we're talking about autoregressive. So now for this now, just I need to change what? The type, and make sure you remove the coding for the unstructured for adjustment of degrees of freedom, and run this. So now you are getting something here also. Yeah, so we just continue doing this fitting. The next one, remember the variance, there is another one. And it can be more, VC for variance component. I'm going to have another one for VC, and also VC. So I'm going to change this only for VC. I'm going to have another one, remember, topics. Although it's not in a PowerPoint, but I'm going to, which is TOET. So I'm running like many of these.
Variance.
Yes, variance covariance. Okay, now the next, which one I should report?
UN.
So let's go back to the PowerPoint again, and so here,
Yes.
which model should I use?
Asma.
UN.
So it's saying that the model, as you can see, you're going to look at the best model that fits your data well. How you decide?
This one.
That based on what is called ACX information criterion, or AIC. The smallest, the better. Yeah, remember the negative binomial and Poisson?
Okay.
Okay. The smallest,
Who's better?
the better. How you decide between Poisson and negative binomial? Yeah, or the deviance or other. So here, ACX will be used. So now, yes, the next step is, okay, I got this, I need to produce a table comparing those, because I have to decide which one would be better, right? Maybe I need only two, isn't it? So this is the model, the variance covariance model. So first one would be compound symmetry, remember? AIC. So I just need to report each one. I have them already run for each. So for compound symmetry, I have this is 24 something, and then the next one
Unstructured.
unstructured. And then just continue doing this for AR1. This is VC.
So,
Are you getting the same? You can add more.
The smallest is unstructured.
Yeah, so now you're going to compare these. You could do visually, right?
so.
Second
Yeah,
one.
or you can solve them. I'm not sure how, using Excel or just visually. I think it's better, right?
Wait, but
So this is rejected. Rejected. You agree rejected?
yes.
No. No.
Oh, yes, the
Yeah.
reject.
It's not rejected.
Unstructured.
Yes. I thought this is 24. So now, yes, this is my best model. I should make my conclusion based on the unstructured. Give me the better variance covariance to model this data. So the next step is to report that would be my final model. Just like remember the selections, model selection, the best model.
Good point.
So the next step is I have to go back to unstructured and rerun this again because this will produce my best model. Good. Producing my best model, running this is type 3, what I'm going to explain my model. So now it's saying that I'm going to focus on treatment by group interactions, which is significant, right? So that's what he's saying now. The effect of treatment on late over time is different. That's how you explain it. How they differ, you will not know. This is just like an ANOVA test. You need to do what? Multiple comparison to tell exactly how they differ. Yes, Banfroni or 2P. So you need to add, remember how we generate these Banfronis? We have to add a code for this. We know this is our best model now, the UN. We're gonna go back here down. This is the best. The best model, which is UN. Any further analysis, I would be using the UN. So what further analysis? I already saying that there is differences in lead level by treatment over time. But I don't know which treatment is better. Is it the active treatment or yes?
But the assumption is fixed effect.
Yes, this is a fixed effect models.
Yeah.
But now these are modeled here. Your random effect, you mean?
Yeah, because when we saw it was random.
Yes, it is already random. It's considered.
Plot, we decide it's random now. Not random intercept,
Yeah.
random slope.
No, that different modeling. Maybe we're gonna cover it.
من
Middle plot, yes.
من البلوت يعني we saw that it's random.
Yes, but we still we need to produce the random intercept model and random slope model maybe next week, and then we can compare which one.
Okay, I need to produce the random.
Yeah, there is two models or three models.
For the same unstructured model.
Yes, like these can be added.
Okay.
Or we're gonna put the random intercept model.
Mhm.
We're gonna put random slope model. We're gonna put random intercept and slope. So we're gonna try all different modeling to fit this, and then come up and see again, compare whether we
I
decide
see.
is still the UN is better or the random intercept is better. So this is one of the
يعني not based on the plot.
yeah, based on the plot you have seen observations, but
Observation wise, it was random, but with random.
right. So I'm gonna save this for next week to add the random intercept, random slope model. But again, looking at this, so this is my model that I'm going to use. There is not enough information to know about which treatment is better. So the next step is
So
to find more here. Remember the LS mean? The LS mean statement I'm going to add. After I decided what model to use, I have to explore further on what treatment is better than the others. So to explore this further, remember I need the post hoc to tell exactly what treatment different than others. So LS mean, I have to put the interaction, which is between treatment and week. Remember? Treatment and week. And then slash for options. You will put
so
just adjust equal to key. Do you remember anything else? No. That's it. Adjust equal to key slice. I'm not sure if it's going to give us
yeah.
a plotting. The mix may not give us a plotting. Slice by treatment, right? You wanted to see treatment? Yes. You will get a long table
Yes.
for comparison, which is the two key. Find it.
Can we do plot? It's better.
I don't think the product mix like the what is called the GLM. In GLM, if we say ODS graphic on, ODS graphic off, it's gonna give you plot with LS mean.
Yes.
In product mix, it may not give you the plotting, but we can look for like Excel or any other type, or even SAS if you're trying to make a plot in SAS. But for now, let's look at the table. So we know this, right? What is new now? We are getting what? We are getting this table of the estimate. I think this is a nice table. We can graph it in Excel. It's easier.
From the table, you can see, you can know which
Yeah, exactly. This is the B value next. The big table will tell you. I'll explain it. But this table giving you what? The estimate, the mean for each. So the mean of active treatment at the baseline is 26. The mean of active treatment at week 1 is 13. The mean of active treatment at week 4 is 15. The mean of active treatment at week 6 is 20. Again, the mean of placebo at baseline is 26. The mean of placebo at week 1 is 24, and so on, so on, so. As you can see, compare this 0 and compare this 0. It's comparing the placebo and A, right? 26 and 26 exactly the same at the baseline, which is good, right?
Yeah.
So that means they start on the same average. So that means there is no differences when they start the treatment at the baseline. 26, 26. Now, at week 1,
The active treatment is this.
so now you're getting this 13, you're getting 24.
Better.
Yeah, it's more reductions. Week 4. This is how you compare. You compare at the differences at week 0, the differences at week 1, the difference at week 4, the difference at week 6. But you cannot compare week 1 versus the baseline, because already there is one more week here. You cannot compare those. You can compare 0 versus 0, 1 versus 1, 4 versus 4, 6 versus 6. You get this? Later we're going to come back and do plotting for this in Excel. Now, still this is will not tell me whether there is a significant difference, right? They have to look at the B value from Toki. Each one of these are Toki. And again, similar to this. I'm interested in a specific. This is called a multiple comparison. There is some comparison that I'm not interested in. There is some comparison I'm interested in. Okay? Some comparison just useless. So I'm targeting a specific comparison, which is differences between two treatments at the same time point. So now, do you think I'm interested in this one?
Baseline?
Differences between the active treatment at different week.
No.
I'm not interested. Why? Because these are different week. It's same medications. For now, I'm not interested in this.
No.
Week 4, no. No. Look at this. Yes. Tell me why. Because different treatment and at what?
Baseline.
Baseline. Both of them baseline. Now this is good to compare. What is the B value? The B value, this is the B value here, the last one. What do you think the B value would be? Significant or insignificant? Insignificant. You have seen this. So the B value is 0.7902. That means insignificance. There is no differences between placebo and the active treatment at the baseline. The B value of Toki is 0.7902. You got this? Then, do you think I'm interested in this? And tell me why. Different treatment, but different time. But different time. Yes, different treatment, yes. But different time, no.
Same time.
Definitely there will be a difference because they different time. And now,
One more. Go for
and then go for 1-1. One right there. Significance. You get this? Which one to take? Which one you don't take? You understand it?
Yes.
I'm against.
You don't understand it?
ممكن أنا أبغى a different treatment in two different times. Assumption.
إذا كان
It's
placebo.
okay.
فهمت قصدي شو؟
I understand.
أي.
But what your logic behind this?
Placebo ما
To
تجي.
see the
Yes, it is possible مع treatment لكن different time. Definitely you will see a difference. لأنها different time يعني زي أنت بتقارن شنو؟ بتقارن في شيء ما في يومه. يعني لا يمكن تجي this is introduced bias حتى. لا يمكن تجي للبصيبو تستخدمهم اليوم مثلا to compare it مع after 1 month. في changes بيحصل صح؟
طيب ممكن I attribute this placebo for something. Sometimes in some study they use it for attribution.
ما في مشكلة.
إيه؟
If
هو
you
على حسب
give,
السؤال.
if you giving argument
لا
ما عندي
والله
مشكلة.
بس الغرض انه
لا، أنا معاك.
open discussion of out.
definitely أنا معاك لكن if you give a reasoning why you are doing this ما في مشكلة بس my part is to make you understand why that is not make sense. So it doesn't make sense if you're going to measure them in one group like a week before and the second group but like next 2 weeks and then you say I'm going to compare them because they are different treatment but at the same time they are different time. The measure definitely will be different without the effect of treatment.
Because لأنه my يعني justification لأنه placebo I know it's placebo it's not gonna have any effect so it doesn't matter if I measure it in the first or second it's still the baseline.
بس هذا بايس.
فهمت القصد؟
Yeah. But it's
فإذا
still,
لقيت difference this difference may attribute to placebo effect or something else.
but there is no placebo effect. It is placebo, so placebo doesn't have an effect anyway.
It has effect. هذا
بس
الكونسيبت
بس فهمت الايه الكونسيبت الاول انه we don't need to compare different time even if they have different treatment. Same thing. It could be same time but same treatment.
yes.
Yeah.
We're not interested. So now over this, yes.
هنا في A and placebo on week 1 there's reduction -11 the estimate.
Yes, the estimate here for week 1. Yes, this is the reductions. It is negative. Why is negative?
Reduce the level.
Which one reduce the lead level? Look at this. Which one come first? Yes, it reduces it, but this is how. Look at this. Which one is larger? You think?
The placebo.
Placebo, right?
Yes.
So now A minus something small minus something large. It's negative. So your question is why we're having negative or?
كيف نقول
Oh yes, the interpretation here. The differences between the active treatment and the placebo at week 1 having a reduction of 11, right? With significant 2p p-value of 0.001.
There is a significant difference.
If you say that I need to know the directions, which one is better? Remember the first one we have done?
دائما الأول نفس الثاني.
Yes, this one. Just tell us significance.
There's
Why we are doing multiple comparison? To tell more story, which one is better, right? So clearly here, which one is making reductions? The active treatments because we have a negative here, negative 11.
يعني by 11
The reduction by 11, yes.
okay.
دائما first minus
Yes, as it comes here, first minus that. Second.
So in the first table there
And,
is
yes.
a difference.
And if the placebo come first, what do you think this would be positive or negative?
Positive.
Positive. Yep. So now going to 2, right? Or do you have 4? 4,
Four.
not 2. So 4 here. Significant 2, right? What is the reductions? It's 8. And going to 6, right? What is the reduction? 2. It is significant?
No.
It's 0.06, marginal, but not significant. So what do you think where the active treatment works better? At what time?
Week one and week four.
Week 1.
I need 1 point.
Week 1.
Week 1. Because most of the reduction it happened week 1. And now we're going to target that. Okay, maybe we don't need to give like the medications for 4 or 6 weeks. Maybe it's enough to give it for 2 weeks or 3 weeks. And then we start the medication. Because they're having most reductions. At week 6, there will be no differences and the drug may not be ineffective. Would be just like the placebo, right? Okay, now we wanted to see a plot.
Nothing easy.
The plotting, I'll go back to this means here. I'm gonna copy this part. I'm going back to Excel. Paste it to Excel. I have to rearrange the data. So rearranging data, I'm gonna put A, I'm gonna put placebo like this. I'm going to put the week as well here. And now for this week, we start with 0, 1, 4, 6, right?
0, 1, 4.
If you're interested more, just to see what I'm going to do, I'm going to put just border for each.
صح كثير.
إذا كله في الاختبار حالي سؤالك.
كل هذا بنسويها عشان tables.
Yeah, just ready for, be ready for. So now, I need to complete this now.
يعني كمل.
Just restructuring to make it graph. I can graph it. So I put week here at 0. So I'm going to copy for A at the 0, and for B at the 0, right? 26, 26. I'm going to copy and put them in the right cell. You know what I'm doing? So at 0, A0, they would be under A0 cell here. At placebo 0, they would be at placebo 0 here. Next, at 1, A1 will be under A1, and placebo 1 will be under placebo 1, and 4, 1, 4, 1, and 4 placebo, 4 placebo, 6A, 6A. Yep. Do you understand this? Why we're doing this? This structuring for graphing purpose. My next step is so easy. You know how to do this, right? Yes. You just need to highlight everything here, and go to graph. You see graph somewhere. So insert, I think. Once you highlight, insert, you see lines. There is one is comes, just, I'm gonna remove this.
What's this? Week.
insert after insert what?
Insert, highlight, أول شيء highlight.
Okay.
Insert, you see lines